Today's professional learning is going to be about error analysis and directive word problems. So, within error analysis, we're going to be talking about the components of our instructional platform, explicit instruction, as well as fluency. So, what is error analysis? Error analysis consists of determining what errors students are making, why they're making those errors, and then what we can do to remedy them. So, error analysis in turn informs our instruction. And most importantly, within Spiral, it determines our next steps for supporting individual students. So we hope that in Spiral, that means time spent in small group instruction or even one-on-one intervention. So within error analysis, you might analyze work samples or you might conduct diagnostic observations or interviews. So let's start with talking about analyzing work samples. When you're analyzing work samples, you are going to see slips and bugs. And I'm going to explain what a slip is and what a bug is. A slip is an error that is not indicative of misconceptions, and it can often be remedied with better organization or self-monitoring skills. So oftentimes as teachers, we categorize these as silly mistakes. A slip is something where you point it out to a student and they're like, oh, of course, I knew that. I'll try not to do it in the future. That's why with slips, we can help students to avoid those silly mistakes in the future by teaching them different organizational strategies and giving them self-monitoring tools. The other error that we might find is called a bug. And a bug is indicative of misconceptions. So we want to spend most of our energy attending to bugs. So when we notice a bug, which often we can find when we see a pattern of errors, that's when we really want to provide targeted small group instruction or even reteaches to try to deal with those misconceptions. So let's look at some work examples now. Here we see 4 examples of student addition. So I want you looking specifically at this 4th example, because if you look at the first and the second and the third example, all 3 of those have been solved correctly. So we don't yet see a pattern. But what do we notice on the 4th example? Do we think that this is a slip or do we think that this is a bug? I see slip. Thank you. What does it look like this error is specifically? What error did the student make? I'm seeing organization, not organized, absolutely place value. And so what can we do to help this student not to make this slip again? Go ahead and in the chat, what's something that we can do to help students moving forward? Oh, that's a great idea. So students can use centimeter graph paper to make sure that their digits, grid paper, to make sure that their digits are lined up. Hundreds column, tens column, ones column, drawing a place value chart. That's a fantastic idea. Turning notebook paper sideways so that the lines are up and down. That's excellent. So one other thing that you can do obviously is, well, to teach students to carefully line up numbers by place value, but you can also teach them to draw lines to separate the columns. So here in this example, you see that the student has carefully lined up the place value and drawn the line. In one of the intervention projects that I'm working on, we always tell students to draw the line and circle the sign. And so it's this automatic, they know before I add or subtract, I separate the place value columns, I circle the sign to make sure that I'm paying attention to what operation I need to use, and they go from there. All right, let's look at another set of work examples and let me know in the chat what you notice. So for those of you that are saying bug, what specifically would you say this bug is? What misconception do you think? Regrouping. Yep. Found the difference, but not the correct order. Absolutely. So this student has a misconception that the digits from the minuend are interchangeable with digits from the subtrahend in order to make subtraction easier. So, for example, in that second problem, 70 minus 19, they weren't sure what to do when 70 has a 0 in the ones place and they need to subtract 9 ones. And so they flipped those digits. And really, instead of solving 70 minus 19, they solved 79 minus 10, which is not the same. And so how would we help this student? Go ahead and in the chat, what is something that you would do to help this student moving forward? How would you address this bug? Place value blocks, yeah. That's what I was thinking for sure. Models or manipulatives, absolutely. So we're bringing in multiple representations, strengthen that place value understanding. Place value mat, absolutely great strategies. I know for me, when I show them, oh, you know what? You did a great job solving 79 minus 10, but 79 minus 10 is not the same as 70 minus 19. So you actually solved a whole different problem. And sometimes that helps them realize what's going on. All right, let's look at this other example. And I know there's a lot going on there, and that's a bit of a hint. What do we notice here? The student understands how to solve one digit by one digit multiplication correctly. Absolutely. So we see 5 times 2, they found the product of 10, 4 times 3, 12. So we see a breakdown when we see 2-digit by 2-digit multiplication. So this is an example of not necessarily a small, misconception, not necessarily a bug, but an opportunity to provide instruction. So for example, we've given y'all the addition and subtraction whole number computation intervention tracker, as well as the multiplication and division whole number computation intervention tracker. So for this student, you might see, well, great, they have mastery of multiplying one digit by one digit numbers. But here they're really needing some intervention with multiplying 2-digit numbers by 2-digit numbers. And so it's not always going to be, oh, this misconception is really very clear. I know exactly what needs to be cleared up so that they can be more successful. Sometimes it's, man, looking at these work samples, they need a lot of instruction on, this certain set of skills. And so it's not always going to be super clear. Here's the misconception. Here's how I target it. Sometimes it's just going to be indicative of this student needs instruction and this student needs guided practice. So with that being said, I'm hoping that you have gathered some of your own students' computation errors. You're going to look over your students' computation work and see if you can each identify an example of a slip and an example of a bug.
So if you could in the chat, briefly tell us about one thing that you and your group discussed. So it seems like we talked about cooperative work to help students with error recognition. I like that. Like, let's work with our peers. Someone said they talked a lot about models for regrouping. Ooh, hopefully those were some visual or concrete models. People talked about different multiplication bugs and decimals, and one of the things there that's lining up. One of our groups talked about different ways to support all of our students in noticing mistakes. I like that. Oh, we had a group talk about subtracting across zeros. That is always tricky. Let's see, we had another group that talked about how students may not understand the concept of a 2-digit number multiplied by another 2-digit number. And one group talked about making mistakes on purpose. I like this, to give students a sense of purpose that it's okay to make mistakes. Yeah, it's really great when, yeah, younger students can see adults make mistakes, whether that's on purpose or whether that is actually a mistake, just so that it doesn't seem that we're all accurate 100% of the time, but it's a good learning experience whenever we make an error. All right. Thank you for sharing those things in the chat. So now we are going to continue our conversations about slips and bugs by thinking about one of the ways that we could help understand a little bit more about students' slips and bugs, and that would be through a diagnostic observation and an interview. If we do this, this provides a really strong picture of what students think, and it helps us be collectors of information. So we're not providing instruction, but we're really learning from the students about what they know. And so, some tips if we're considering a diagnostic interview, if we're going to do this, we want to accept students' responses without any judgment and really keep our responses to what students are saying neutral and ask a lot of questions about both incorrect responses, but also correct responses. And this is one of those things that's important to do so that students don't, if we respond, they don't think, oh, I got it wrong, right? Like, oh, Sarah only ever says something when I answer incorrectly. No, Sarah says something all the time, right? So thinking about those questions to incorrect and both correct responses. So this comes from a really great book about error patterns in computation. I am sure that some of you are familiar with this book by, I think it's like Robert Ashlock is the author's name, has a lot of good work on error patterns. But in the book, they provide a script that we might be able to use to get into, well, what are students thinking, particularly around their errors? So I might say, all right, here is a problem. Go ahead and read the problem, please. So the student reads the problem. And then I would say, well, what is the question asking you to do? So immediately I'm starting to get students talking about maybe the operation, maybe, oh, I need to multiply here, or maybe I need to add. Maybe they have a multi-step problem that they're going to be asked to answer. And then I would follow that up with, well, how are you going to find the answer? So before students even start to do the work, I want to know about their plan. All right. So tell me a little bit about your approach to solving this problem. Are you going to, add the ones, then add the tens? Are you going to use an array to do multiplication? What is it you're going to do? And then you would ask, okay, go ahead and do this problem and tell me about your thinking as you work. This is hard for students if they have not done this before. Not every student is really good at a think aloud as they work. So you may need to prompt them like, "Oh, tell me about what you just did here. Oh, tell me how you added those numbers." But what we want to get is an idea of what is the student's continuous thought process as they do whatever problem they're working on. And then at the end, you would say, write down your answer, and you may have a question about that if it's not very clear. But this can really give you a good idea of what students understand and where students might benefit from some additional instruction. And then as you think about after they've solved this problem, other questions you might consider asking are, well, how did you get that answer? I may have missed something. So that might ask students to go back and think about, how did they get to their final answer? And then I really like these other two prompts. These are really great prompts to get at student thinking. So the prompt in the middle says, if I had to teach someone else to solve this problem, or if you had to teach someone else to solve this problem, what would you tell them? And so this might be like a really good way for students to show off what they know about the math problem. It also might show you some of the gaps in their thinking. And then I love this one at the beginning. All right, this time I'm going to hold the pencil and I want you to act as the teacher and tell me what to do. When people teach, whether that's adults or whether that's younger students, you see so much about what they know. And so giving students the opportunity to be the quote teacher and letting them walk you through that process, you're going to see a lot there that'll tell you quite a bit about student thinking. Now, you can keep track of all of these diagnostic interviews, and so you can put these in some type of spreadsheet like this, but we're really focused in Spiral on those next steps for instruction.
So, just to review, we have slips and we have bugs. So, for slips, we can teach students to organize their work, write neatly, and check for mistakes. We can also introduce self monitoring checklists. So, here in this example, it says turn in this checklist with your assignment. And students have to check yes, no, or not sure for my digits are written in place value columns. Others can read my numerals. Sometimes I was stuck. I checked my answers, as well as describe a situation in which this computation could be used. So, this is an example of a self monitoring checklist. Before the student turns in their work, they run through that mental list of did I organize my work? Did I write neatly? Did I check for mistakes? This is an example when I taught second grade of a base 10 block strategy checklist. So, what I did is I conducted error analysis quite frequently and I figured out what errors the bulk of my students were making. And I used those errors to create a checklist so that students could check for all of those frequent errors before turning in their work. And so I wrote, are numbers represented correctly? Did you separate the two models? Because we're putting parts together into a total. Are your ones and tens organized into 10 frames? Did you regroup when necessary? Do you have neat work in handwriting? And so, based on what errors you notice that your students are making, you can create a checklist that students can use to self monitor and try to avoid those common slips moving forward. Now, bugs are trickier. Bugs we want to put a lot more thought and planning into. So, when we notice that a student has a bug or a misconception, we want to make sure to then provide step by step modeling, guided practice, as well as timely feedback. So, this ties back to our explicit instruction component of our Spiral instructional platform. We also want to make sure to provide students with opportunities to use hands on manipulatives and visuals because often misconceptions can be remedied through multiple representations. And lastly, once we have remedied a misconception, we want to make sure to build their fluency with that skill so that they don't backslide into those same mistakes. So, we want to provide brief daily fluency practice once students become proficient with skills, especially computation.
And then when it gets to bugs, we really want to think about, well, what could we use in our instructional platform that been talking about in Spiral to help students with those bugs? So we want to rely on our explicit instruction. Remember, that's always modeling and practice with timely feedback. As we provide that explicit instruction, it's going to help the students understand mathematics better. Those representations that we've talked about in Spiral, particularly hands on manipulatives, or maybe you're using virtual manipulatives, those can be really helpful here in addition to drawings. And then fluency building is going to be a very helpful part of helping students with any of their bugs that they have in terms of their mathematics thinking. And in Spiral, we're emphasizing that brief but daily fluency practice. Fluency with facts or fluency with computation, both of those things are going to be helpful for helping students avoid some of those bugs in the future. So, what questions do you have about error analysis? What are kind of some of your things that you also want to know about error analysis? One of the questions I always have about error analysis, maybe you're thinking at the same thing too, is when do I have time for this, right? I know your days are really busy and there's so much that you're doing in the classroom and also outside of the classroom. But you don't have to do a lot of error analysis to learn what students are thinking. So when we are looking at that diagnostic interview there, if like, oh, hey, I want to give this problem to this single student and talk with them about what they're doing, usually you only have to do one or two of those problems to really understand, okay, this student does not understand regrouping when it comes to addition, or this student doesn't seem to understand what multiplication actually means or what a fraction means. So a few error analyses typically go a very long way. So we are going to move on to the other content for this session here today. And the content for today was asked from our spiral teachers from last year. And so at the end of the year, we administered a survey to all of you, and probably many of you responded to that survey. And what were some of the things that you said you wanted to focus on in spiral this year? And one of the things was error analysis. So, what do I do when my students are making these mistakes, often within a computation problem, but those errors can occur anywhere in mathematics? And then another ask from all of you was, well, what do I do with word problems that don't fall into those categories of total, difference, change, equal groups, and set problems? And so that brings us to our conversation today, which is around directive word problems. So, where are we in our instructional platform? We are here at the bottom where it says problem solving. And so, we are going to focus on that problem solving part of our instructional platform. But I will just let you know, and you probably know this is coming already, all four of those things at the top of the instructional platform are really important as we focus on these directive word problems. So a directive word problem looks a little bit like this. Look over here on the right-hand side, and we see the following problem. Yolanda wrote a number. The digit in the millions place is an 8. The digit in the thousands place is a 6. And the digit in the hundredths place is a 2. Which number could be the number Yolanda wrote? Now, this is a directive word problem because students have to read the word problem, but the word problem gives them a direction to do something. So here, the students are directed to identify the number that Yolanda wrote. Students aren't reading this word problem and taking information and using it to add, subtract, multiply, and divide. All right. That would be a routine word problem. And those routine word problems would fall into the categories of total, where we put amounts together for a total, difference, where we compare amounts for a difference, change, where we have one amount that increases or decreases, equal groups, where we have groups with an equal number in each group, or those set comparison problems where we have a set multiplied a number of times. All of those are routine word problems. This problem here is a directive word problem. So again, I'm not taking numbers from the problem and putting them together or comparing them or multiplying them or whatever. But instead, I read this word problem and I'm given a direction to do something. Here, it's to identify the number that Yolanda wrote. On these problems here, we have different directions. So let's look at the problem on the left-hand side. I will start it at the top where it says the list shows the number of points a basketball team scored during the games the team played last season. In the chat, I'd like you to tell us what is the direction that students are given in this problem. Basically, what do students have to do in this problem? All right, let's see who's read the problem and what is the direction that students are given here. All right, so we've got some suggestions coming into the chat. Find the number that is missing. Yep, that's the direction. Find the relationship, right? So that is why this is a directive word problem. We have to just figure out which number of that which leaf, I would say, is represented or should be represented by that square. So the direction there is to figure out the missing number. Let's look at this problem on the right. A worker is building toys at the factory. And here you can read the rest. It's talking about a relationship between the hours that the employee works and the number of toys the employee builds. And then that's represented by this equation. And so, what is the direction that students receive in this problem on the right? All right, so here the direction is to figure out which is the matching graph to y equals 9x. Yeah. So which of the graphs follows a rule, which of the graph matches. So there we see that's the direction that students have to figure out. Now, the thing about these two word problems that we see here, one is a fourth grade problem, one is a fifth grade problem, they are very text heavy. So they're very similar to routine word problems, and that routine word problems involve students reading quite a few sentences to figure out what question they're going to answer from that word problem. Here, students have to do the same thing. They have to read quite a few sentences. Often these are accompanied by different types of visuals, like we see a stem and leaf plot, or we see these like coordinate planes over here. And then they have to answer a question, but the question isn't usually going to ask them to add, subtract, multiply, or divide. Instead, the question is going to ask them to either fill in a stem and leaf plot or figure out which graph matches, or it could be a number of other different types of directive word problems. So, when we think about these directive word problems in the chat, tell us a little bit about how do you teach directive word problems in your regular math instruction? So, do you incorporate them at all? And if you do, how do you teach these different types of directive word problems? So let's think about how we can use our entire instructional platform to help students with these directive word problems. Well, as it says here on this slide, high quality explicit instruction is always a very good place to start. So here is our model of explicit instruction that we rely on in Spiral. Part of that model, which is the modeling part, involves using planned examples and providing a step by step explanation for how to solve a problem. So if I'm working toward, I'm going to go ahead and put it there, this problem that you can see at the upper right hand corner there. I may really want to do some explicit instruction on just interpretation of a stem and leaf plot. So, how do I read each of these numbers? And then maybe I get into a stem and leaf plot where we have this key. And so, how does that help me better understand the stem and leaf plot so that I can work toward this directive word problem where I have to read all of that text to then be able to answer the question about what fraction of the teams raised this extra money. Now, as I do that, and as I get into those directive word problems, I may want to be really explicit about, well, what are we doing today? Well, today we're solving a word problem with some graphs. And the first thing we're going to do is UPS check it, which I know one of you already mentioned that you're using. And I hope some of you are also using that same UPS check attack strategy. And then we want to engage students in practice around, well, in this example, interpreting that stem and leaf plot. That practice might be practice in small groups or peer practice. It also could be individual practice. There's lots of different ways that we can practice. One of the best ways to practice is when the teacher, that's you, and your students are practicing together. So that's a nice way to scaffold support for students before they move to independent practice. And then we also want to think about, well, what are some of the visuals that we should bring in to really help students understand the mathematics? So that's where those multiple representations can come into play. Here, if I was doing things with stem and leaf plots, I might use base 10 blocks or maybe those place value discs. Those might be helpful, but you might use other visuals such as I don't think you'd use fraction tiles with this one, but you might use some other visuals as well. And then as we continue with our explicit instruction, we want to ask a lot of questions to students. This gets at what students are thinking. High level questions are important, such as explain this, what the problem is asking you to do. Low level questions are also important, such as what is the value of this number if the stem is 3 and the leaf is 1? And then as students respond to those questions, they might provide verbal responses. They might use gestures such as a thumbs up, thumbs down. They also might respond by writing or showing things with manipulatives. And then as students respond, it's really important that we provide feedback. We want to provide affirmative feedback to students. Affirmative feedback is always the best when it's mathematics specific. And we want to provide corrective feedback to students to help students understand where they may have made an error and then how we can help move on from that error. Now, the other thing that we want to think about in terms of our directive word problems is vocabulary. this is the second part of our instructional platform for Spiral. These directive word problems are loaded with vocabulary terms. So we want to make sure that we build student vocabulary knowledge so that they can understand the words that are in these sentences that are in these different types of directive word problems. So building vocabulary knowledge is key. Maybe you want to use some of the vocabulary cards that we've put together for the Spiral project. Probably some of you already have your own vocabulary cards, but we're going to look at this problem in just a minute. I want you to see how many vocabulary terms are in this problem. So to be able to think about this problem and to solve this type of directive word problem, I have to understand what perimeter means. We should likely understand centimeters. Then I want to understand also what area means. And then I'm asked about which model could represent this rectangle. So I should be able to know what MODEL is and how that's used in a mathematics sense, particularly in this question here. Then, as we continue with our instructional platform, directive word problems are often going to use a lot of visuals. We already saw the visual of the stem and leaf plot. We saw the visuals of those graphs. We're going to see the visuals, we saw the visuals of those rectangles or squares. And so we really need to help students be able to understand these different visuals. So including multiple representations in your instruction is going to be important. Remember, those multiple representations might be those concrete hands-on tools. They might be those pictorial representations that could include virtual manipulatives, or maybe that is drawings on a whiteboard or already prepared drawings. Maybe your visual representations are different types of graphic organizers. Charts and graphs are also multiple representations that might be important to practice with your students so that they have that familiarity that will allow them to answer these different types of questions. So here's an example from a directive word problem. Here, students are expected to read these visuals to determine which of these represents a price that's greater than $1.60 but less than $1.90. So the visuals that are there in the problem, but maybe you want to use virtual manipulatives. So there's an example of a virtual 10 by 10 grid that you can color in to represent something very similar to what students would see on this star question. You also might want to use base 10 blocks. That would be a really nice hands-on manipulative to use that helps students see, well, how could I move from the base 10 blocks to interpreting these visuals of prices? So multiple representations, really important for both conceptual and procedural learning. Then we get to fluency. Directive word problems can often be lengthy. I am going to have to go back and double check this stat, but we looked at grades 4 and 5 word problems a few years ago, and on average, there were 27, I think that's right, 27 words in each of those problems. Now, that means that some of those problems had fewer than 27 words, but several of them had more than 27 words. And in fact, I think we found a word problem that had over 50 words in it. Students have to read all of those words and then put all of those words together to construct a meaning of the directive word problem. And so we don't want to put on top of that, oh, you have to, still work on computing these facts or doing this difficult computation. So, if students have fluency, particularly math fact fluency, that's going to free up students' working memory so that they can focus more on the reading, particularly when the reading involves complex sentences. So, I want you to look at this problem. This is one that the Spiral team has talked a bit about. All right, let's look at this problem here. Look at the kind of purpley shaded areas. So Cassidy walks and bathes dogs. She charges $8.50 if a customer wants a dog bathed and walked. She charges $5.75 if a customer only wants a dog walked. I'm not going to continue reading. All right, you can read the rest of this problem on your own. Then it says Cassidy used this expression to determine the amount of money she earned walking and bathing the dogs. And the question asks, how much money did Cassidy earn walking and bathing the dogs last weekend? Now, someone's going to count for me and maybe they'll drop it in the chat. How many words do we have to read this entire problem? But ultimately, the thing that you have to do to solve this problem is to solve this equation. So, not that I'm going to skip the reading. I think the reading is there and it's kind of helpful for situating where did I get these numbers from and what do these numbers mean? But I have to have computational fluency to be able to solve this problem. So, first, I'm going to figure out, well, what do I do within the parentheses? And then I'm going to multiply each of those amounts 5 and 75 hundredths times 11 and $8.50 times 8. And I should say $5.75 instead of 5 and 75 hundredths. Sorry about that. And I'm going to do the multiplication and then I'm going to add those numbers together. And so think of how much reading is necessary to kind of understand what's going on. But if my fluency wasn't as well developed as it could be, then it's going to be very taxing to try to solve this directive word problem. And then as we get to our problem solving component of our instructional platform, which is where we've been for the past 20 minutes or so, let's remember those two things that are important for problem solving. Using an attack strategy is one, and focusing on schemas is the other. Now, we don't really have schemas in play right now in these directive word problems. So, this means we can just solely focus on using that attack strategy. We will use UPS check, but you use whichever attack strategy you prefer to use. So we are going to do a problem here together. This is number one on your printable. If you are interested in either following along and doing some of the work with me, I will say that for our next breakout room, which will start in just about 5 minutes or so, we will get into number two and number three on your printable. So please have those nearby. So we have a directive word problem here. This is a fourth grade STAR question. Probably those of you who work with students in grade 4, you've probably seen this released item or items similar to this. So I would expect that students would be asked a very similar question about perimeter and area on the STAR in 2024. So let's think about how we could use our UPS check attack strategy to solve this problem. Now, before I get to that attack strategy, I want to think about, well, what vocabulary is going to be really essential here? So I see vocabulary of perimeter and area, and maybe we also want to know the vocabulary of model. That would be important to understand here as well. And then I want to help students understand this problem by making sense of what the problem is asking them. And students must have a skill with being able to calculate the perimeter as well as calculate the area of different shapes in order to be able to solve this problem correctly. So, right there, I see a lot of knowledge and skill that is necessary to be able to solve this problem here at fourth grade. So let's think about how we could use UPS check to help students understand this problem. So the first thing I want to do is write UPS check. We do that for routine word problems. We want to do that for directive word problems as well. And so I'm now going to understand this problem by reading it. A rectangle has a perimeter of 40 centimeters and an area of 64 square centimeters. Which model could represent this rectangle? And I see here I have four answer choices: F, G, H, and J. Now, after I understand that problem by reading it, I really want to ask myself, well, what's going on in this problem? Well, I see in F, H, and J that I have three rectangles, and then in G, I see that I have a square. So if I'm thinking about perimeter of rectangles, I know that I need to add the lengths of the four sides together. And then if I'm thinking about what I do of the area of rectangles, that means I would multiply the length times the width. And I would do that for each of those rectangles. So I'm doing all of this thinking about area and perimeter to help me with the understanding of what I'm going to need to do in this problem. So as I continue, I think, well, I need to figure out which of those models or which of those shapes has a perimeter of 40 centimeters. So maybe I want to keep that top of mind. So I'm going to underline that. And then I also need to figure out which of these has an area of 64 square centimeters. Again, I want to keep that top of mind. So I'm going to underline that. And at this point, I feel like I have a pretty good understanding of what I need to do in this problem. So I'm going to go ahead and check off that U, and then I'll move to the P of UPS check, which is to make a plan. So now my plan is to figure out, well, how do I approach solving this problem? So maybe I would say, well, I think the first thing I'm going to do is look at each of the models and figure out which of these models has a perimeter of 40 centimeters. If it has a perimeter of 40 centimeters, then I could figure out which of these has an area of 64 square centimeters. But if it doesn't have a perimeter of 40 centimeters, I could cross it out and move on to the next shape. So let's go ahead and think about this. And I'm going to make a note of this so I don't forget. So first, I'm going to focus on perimeter. That's my step one. And step two is I'm going to focus on area. So let's go to step one and let's first focus on problem F. So now I'm going to start with this solving. So I'm going to start with rectangle F or model F, and I'm going to think about, well, how do I calculate the perimeter? Well, I know if the length of the rectangle is 32 centimeters there, then I know this is also 32 centimeters. And if I know there that I have this width is 2 centimeters, then this width is 2 centimeters. And so what I can do to figure out the perimeter for problem F is I can add all of the sides. That means I would add 32 plus 32 plus 2 plus 2. That equals 68 centimeters. 68 centimeters is not 40 centimeters. So immediately I know that the rectangle F is not correct. I'll go ahead and cross it out and then move to G. When I look at G here, with G, I see that one of my lengths is 8 centimeters, so that means the other corresponding length is 8. And then I see the width is 8, so the corresponding width is 8. If I add 8 plus 8 plus 8 plus 8, that equals 32. Wow, well, that's also not 40 centimeters. So that is not going to be the answer to this question. I'm going to go ahead and cross it out and move to H. Then as I get to H, I see that I need to figure out that I've got 16 centimeters and 4 centimeters. I may even draw those or write those on my visual. If I add those together, that does equal 40. So that tells me that H might be the answer to this directive word problem, but it also might not. I need to continue. But I'm going to now check out J. All right, so let's see what happens with J. Here I figure out the perimeter of J, that is 11 plus 11 plus 9 plus 9, that also equals 40. So now I'm working between H and J. I have finished step one, which was a focus on the perimeter. So now it's time for me to focus on the area. That's step two. Now, I don't have to do that for F and G because we've already crossed those out. Those don't apply. They do not have a perimeter of 40 centimeters. So let's see which of these has an area of 64 square centimeters. To figure out the area, I need to multiply the length times the width. So if I do this for H, I do 16 times 4. 16 times 4 equals 64. Wow, well, this seems like a pretty good contender for answering this question, but I'm going to check that J also doesn't have an area of 64. So if I calculate the area for J, that's 11 times 9. 11 times 9 is 99. That is not the correct model, so I can go ahead and cross that out. And then that helps me identify that H is the correct response, and then I can check off the S. I have solved the problem. But then I want to go back and check my work. Checking our work is always really important. So here I'm going to calculate the perimeter in the area of H one more time to double check that the perimeter does equal 40 and that the area does equal 64. So I'm going to go ahead and check that out. There's my perimeter and here's my area. And I have double checked this problem. So that's the point where I can put that check mark next to that UPS check to show that I have understood the problem, I've made the plan, I've solved it, and then finally I've gone back and checked my work. Wow. Well, that was a whole lot of work for that directive word problem. But I hope it is a helpful way of seeing how you can still use UPS check to set up and solve these directive word problems with students. So that brings us to our second breakout room. So you have your printable, and that has numbers 2 and 3 on it, and those are both directive word problems. With your group, you're going to discuss how you would model solving these problems for students. And both of these problems might take a bit of time to model. So, really get into the nitty gritty of how are we going to help students understand the direction? How will you use UPS check to solve the problem? Like, what are the things you are going to do in your math instruction? And then, if you have some time and you're thinking about these different types of directive word problems, talk a little bit about what have you found has been really helpful that works for directive word problems, and what are some of the challenges that you see?
All right. So I see that one group talked about all of that math vocabulary that is in directive word problems and the importance of explicitly teaching that vocabulary. One group talked about the importance of the think aloud process, making sure kids understand the basics of those concepts that are often included in directive word problems, such as graphs. One group talked about how many problems have graphs, and we need to teach students about different kinds of graphs and how to read them. Absolutely. Any other ideas? And there's a video on the Spiral website on directive word problems from YouTube, and it's not any brand new content. That's different from today, but if you need a refresher on directive word problems, that video is available for you on our YouTube and on our website. So, y'all, one of the most important things about directive word problems is that it's important to spiral them throughout the year. So, one goal that you could have is to include exposure to directive word problems within each of your units. That way, you're exposing students with directive word problems with graphs in your data analysis unit. You're exposing students to directive word problems with money in your personal financial literacy unit. All of your different units, see how you can incorporate directive word problems. Maybe you include directive word problems in your formative assessments. And we also have directive word problem sorting cards available for you. So we have routine word problem sorting cards. So those are ones that on the back say T for total, C for change, etc. But all of our word problem cards that say no schema on the back are examples of directive word problems. So if you need a resource that's ready to go tomorrow related to directive word problems, you can pull out those sorting cards that have no schema written on the back. But we've also taken all of those directive word problems cards and we've removed the backs from them, and they're in a printable format, a PDF on the website. And so what you could do is you could download those printable directive word problems, which are identical to the sorting cards, but the printable version, students can cut them apart and potentially glue them into math notebooks, and you can use them as a resource to have students solve directive word problems in whole group or especially small group lessons. We hope that we will see you using them. So, do we have any questions about directive word problems? If not, I'd love if everyone could share which practice from this session do you plan to implement first? So think about error analysis, slips and bugs when analyzing work samples. Think about our diagnostic interviews and observations. Think about directive word problems. Okay, I see error analysis, slips and bugs. Awesome. Self-monitoring checklists for students. All right, so we're digging error analysis. Love it. Having students find teacher errors. Yeah, that's a powerful practice, is having students themselves conduct some error analysis. Absolutely. When I was in the classroom, we did a lot of strong and weak work. and students found errors and discussed them in the week work. So, just like at the end of our last professional learning, we have 3 questions with just basic feedback from the professional learning. And then you're going to be answering questions that will be sent directly to your coach to help inform them of your needs. So the first question that will be sent to your coach is pick an instructional focus that you will work on with your coach. And like I said, those options are error analysis or directive word problems. And then number 6 is what is one way that you will collect student data related to your focus? So if your focus is error analysis, maybe you're going to use your spiral whole number computation intervention trackers to keep track of those errors that you notice, and as well as, make next step plans for how to intervene based on those errors. If you choose directive word problems, maybe you will collect student data through using formative or summative assessments. So I am going to go ahead and launch our poll.
We will see you again either on Tuesday, November 14th or Wednesday, November 15th. So thanks for joining us today, and we will see you soon.